Okay, now we're going to set up the prediction for sales for each of the three models, the linear model and the quadratic model and this model where we had to do some transformation. Okay, so predicted sales for model 1, okay, that's easy enough. Well, y-intercept, make sure that that is absolute referenced, plus slope, b coefficient should be absolute referenced, okay, and then times the advertisement expense, which is here. Okay. Now enter. Now we can copy that for the rest of the weeks, and then we have our prediction for sales for the 22 weeks. So this is model 1. Model 2 is here, beta sub 0, b sub 0, absolute reference that, plus b sub 1, absolute reference that, times advertisement, okay, plus the third coefficient, which is here again, absolute reference the coefficient, times advertisement squared, which we have right there. Okay. Now that's the prediction using model 2. All right. Now model 3, okay, we need ln of, so you can either use this method or that method. So if you want to use the straightforward method, okay, so that will be, you take the transformed y-intercept, which is here, okay, now there is no plus here, but that times x sub 1, so that's the regular x sub 1, to the power of beta, or b, the b estimate. The b estimate must be absolute reference. So that will give us the sales using model 3. And let me illustrate that this is the same as if you had done it in this fashion. Suppose you did not do the transformation here and you want to use the A star and B sub 1 estimate. So first let's get the ln of advertisement over here, so it will be easier for us to see. Okay. Then if we use A star, okay, absolute reference that, now this time we are using the transformed model, so you'll have a plus, and then b sub 1, that must be absolute referenced as well, times the ln of advertising. Okay. Now this gives us an estimate for here y hat star, not y hat itself. So y star is the ln of y. So this is the predicted sales, predicted ln of sales. Okay. Now once we have the predicted ln of sales, then we can retransform back to the original value by going exp, and that would be the same as what we see here. Okay, they both will be exactly identical, as you can see. So this column is the same as model 3, so there is no difference here. As you can see, it will be exactly identical. Okay, so we have 3 predictions for the sales, and let's get the sales over here. So then we can plot them to see how well the different model works in nonlinear curve fitting. Okay, so let's do one at a time, plot one at a time. So we do the sales plot first. Okay, so like that, and let's add the x range. X range is the actual x values, so which is right here. Okay. Now that gives us the plot for just sales. Now let's add the next one, which is model 1. Okay, the series name will be model 1. Okay, so the name is there, Y range is that, and X range is same as before, which is that. Okay. Alright, now we'll add the next one. Model 2 is the name. Y range is model 2 predicted values, and the X range is that. Okay, now finally we'll add model 3. Okay, that's the name. Y range is model 3, and the X range value is the same as before. Okay. Now we can add legend. Let's put the legend at the bottom. Okay. We can change the x-axis range if you like, and maybe we can put like 80 or something. Alright, so you see that the blue line is the actual value, and of the three, the model 2 is probably best fits the actual values. Okay, So this is the second, we have now seen the first category and the second category of dealing with nonlinear models. Now the third one is where you cannot do any transformation, so we have to rely on solver. So we'll look at that next.